Hi everyone and welcome back to Max Electronics. In today's video we will be building a lead acid battery UPS, we're going to be building two versions. There is a beautiful circuit board from PCBWay, as usual, delivering the high quality stuff. So this is a 12 volt UPS based on lead acid batteries that is going to be capable of supplying high current to your device, not super high. 6 amps is the max. Well, it could be a bit higher than that, probably 10 amps that you could draw out of it, but 6 amps of charging on the batteries. Can also be adjustable, so you can have just 1.5 amp charging, or you can adjust the current. The second version, I will explain later, it can be 12 volt UPS, but the output is adjustable, so you can have say 5 volts or 3 volts or whatever you want it to be. And again, this is a UPS, so it's designed to be always on, always outputting power, regardless whether power is supplied to it or not, unless obviously you disconnect the battery. So that's the circuit board, and it's really nice. It's a decent size. It will require heatsink. In some cases you may put a smaller heatsink. In my case there will be a larger heatsink, and I will explain in a second. So we're going to be building two versions, and that's a universal board. So again, if you're just building 12 volt version, if you're building for high current, you will need to fill all those voltage regulators. If you're building a low current for 1.5 amps, let's say, you just need one voltage regulator, and that's it. And again, depending on the rest of the circuitry, what are you doing? It's a universal board. So before I'll explain all this to you and get ready all the component list, which is there's a few components there, as you can see, again, before all this, let's just have a quick word from my sponsor, who is sponsoring this video with those beautiful circuit boards. This video is sponsored by PCBWay. PCBWay is the leading manufacturer of high-quality multi-layer circuit boards with unbeatable prices. Simply upload the zip file with your project directly to the website, select your preferences, preview your board, select the postage, and get an instant quote. Now you're just one click away from getting your project completed. PCBWay also offers a range of services such as PCB assembly, CNC milling, 3D printing, sheet metal fabrication, and injection molding. Your project will be manufactured by highly trained professionals with a state-of-the-art equipment and delivered to you in no time with safely packed and vacuum-sealed packaging. Prototype the easy way with PCBWay. Quality, integrity, reliability. I've got all the components ready on the table, little box here. It's not that many components, as you can see. I've got all the instructions for little jumpers, the ones you need or not, so I've marked all the components with the marked that little mark here. They are not required if you're building not regulated power supply. And that's actually, see that square here, that's on the circuit board marked with that line around. So in that line you don't need to install components if you just want a 12 volt power supply. What other remarks do we have? So if you're not using that precision regulation, you do need to put a jumper here, that JP1. If you are using this, do not install the jumper. Also with the fuses, I've added, where is it? The mini car fuse holders. You can, for those little smaller fuses, so you can put the fuse directly in there. You can also use a bigger fuse, the standard size car fuse in there, or you can use a larger car fuse holders similar to those ones. They fit perfectly in there. Let's go over the schematic quickly and start assembling it. So I'm using a big heatsink, by the way, like that. That's the one that clips on, so there are clips, where are they, that you can place them anywhere, and they just go under there and clip on and hold your MOSFETs or whatever, transistors, voltage regulators, whatever you like. Pretty chunky, and it's pretty much the size of the board, so it fits perfectly. Alright, let's go over the schematic. We've got AC coming in, usually 16 volts, 15, 16 volts is enough. It's got an LED. LED also, you can solder directly, that's the LED, onto the board if you don't want it externally. If it's going to sit in a box, you can put a little Molex connector on there and just have a little wire coming out. I'll show you that later. It's going through bridge rectifier, fuse, which I've used, what is the fuse name? Little fuse. Yeah, that's the name of the fuse. Little fuse. The little fuse is like little round ones. Where is it? Like this. So that's for just transformer. There's 3 fuses in total, 3 protections. So one is on the input line in case the transformer diode bridge goes bad. Then it goes through the voltage regulators, and some people say you can't have LM317T in parallel. Well, you can. If you look at the data sheet, you can hook them up in parallel. We've got a little adjusting trim pot. That's to set your battery charging voltage. A couple of capacitors, filtering capacitors, another fuse, that's the battery fuse, so if something goes wrong here, you want that fuse to go away. And that's a 10 amp, 30 volt, the car fuse. And that's it. So that's the jumper that, again, only install it if you're doing this part here. If you are assembling the voltage regulator, then do not install that fuse. So then again, if you're installing the voltage regulator, it's LM2596 adjustable voltage regulator, a couple of caps, the diode, Schottky diode, 100 microhenry inductor, little trim pot for regulation to depending on the voltage you want, and of course the fuse, a 3 amp fuse on the output, because this module can only output 3 amps, so you've got a 3 amp fuse, and that's it. So bill of materials included, schematics included, all the files are included below. This is a freebie. Of course, this video is going to come out on Patreon first, so all the patrons can see that and copy it, but this time I'm not just sharing the files on Patreon, I'm sharing them below, so you can all make this module. But again, this is only Max Electronics, you cannot mass manufacture it. I will not send you pick and place files. I had a few people ask me for pick and place files, and the only way you'd want those files is for mass manufacturing, which is not what it's for your personal use. Alright, so let's start assembling. The board is now soldered. Again, this is not regulated power supply. I've decided to put just a rising clamp on the AC and just the disconnecting one rising clamp on the output. So this way it is more convenient. That's your 12 volts battery, a standard blade or spade connectors, the fuse holders, that's the Molexes for the LEDs. And what I'm going to do, well, I've already done those. It's the LEDs on the DuPont connector, so this way I can just plug them in, and when I'm putting this into the panel or something, then I can unplug those and plug a normal wired ones, so they are out the front of the panel. So I'll plug actually the red one will go for the AC, and the yellow one will go for the battery. So those indicating the AC presence and the battery presence, or the / output kind of thing. So the red one will glow if the AC is plugged in, and the yellow will glow if there's a battery there. So let's put the heatsink on with those clamps. Yeah, look at that, it fits perfectly. Again, the what do you call it? Bridge rectifier does get warm, so it needs the heat sinking. Alright, so how easy is that? You just clip it on. Yep. Alright, so now that the heatsink is clipped in, everything is ready. So, by the way, the tab, why is it sideways? I'll straighten it up. Oh. That's better. So by the way, the tab on the LM317 is the output, so you can mount it without any isolation to the heatsink, but then the heatsink will be your output, so you can't mount it to, say, a grounded chassis. In my case, this may be mounted to the chassis, so I've isolated it, so the heatsink is isolated in its ground. There's an isolation, you can see that little thing. So that's assembled. Now I'm going to install the fuses. In my case, I'm using a 10 amp fuse for the batteries and 5 amp output. So I don't need more than 5 amps on the output. There we go. Oh, this one's not fully in. That's it. The board is ready. Now let's tune it and let's plug it in and let's tune it. But before that, I'm going to quickly clean off all the flux that I've left here. So I'll clean off the flux and I will be back and we'll test it. Okay, so I've cleaned the board. I haven't lacquered it yet. You don't have to lacquer it, but since it's going to be in a box serving as a UPS, I prefer to add the lacquer layer onto it just to seal everything off. So let's plug it in, make sure all the caps are correct polarity, other way it's going to go bang. So I'm going to connect two wires, and since I don't have a transformer on me, I'm going to be powering it from DC supply, supplying maybe 16 volts. Again, doesn't matter the polarity because it's got its own bridge rectifier. Ideally, you'd want a transformer that is supplying around 15-16 volts. You can go up to 18. It's just it's going to be heat, so because the battery is going to be sitting at 13.6 volts. I know that usually it's 13.8, but in my case I like to keep them slightly under, and this way it prolongs their life. So I've got a power supply here set to 16.2 volts and 3.2 amps. Amperage doesn't matter, so let's hope it doesn't blow up, and here we go. Okay, the red LED is not on, and that's probably because I mixed up the polarity. Let's try that. Yep, I did mix up the polarity when I was plugging it in, so both LEDs are on. Next step, let's adjust it. Well, let's measure the voltage on the battery. And here's the multimeter in the corner of the screen. So we've got 13.7 volts, very close. Usually you set that trim port that is, where is it? In there, to middle, and that's roughly what you want. And we'll adjust it now until we hit 5, 13.5, 13.5. Yeah, around here, 13.5 volts is quite reasonable. So it's drawing 32 milliamps, and the only draw on that board is the LEDs. That's pretty much it. Each LED draws around 16 milliamps. So I've got a lead acid battery here, and it's time to plug that in. It is 12 volt, 7.5 amps battery. I've got a little connectors here, so it is an AC connectors, but doesn't matter, it works just fine. So here we go, we've got the negative and a little bit of a spark. Oh, no spark, positive. So you heard the, it's charging at 1.5 amps and dropping. The battery is not too, it's full, but it's not fully full. It's dropping to 1.2 amps now. So it looks like it's charging well. 1 amp, so yeah, there is zero heat so far. It will get warm, and they are fine. So LM's 3170 fine for up to 105 degrees Celsius, so that's never going to reach that. You probably heard the fan drop out now, that's at 900 milliamps. So we'll leave that on. Let's measure the output voltage. And it's at 13.3 volts. And let's now disconnect the power supply. So here we go. I'm going to disconnect the positive. Oh, you saw the red LED went out, and we're at 12.6 volts and slightly dropping. So UPS is working fine. I'll reconnect the mains again. Yep. So that's it. Now what I would do, usually I'd lacquer the board as well, but with that little trim pod that we just adjusted in that corner there, that little white one, 10K trim pod, I would take a bit of a Loctite and do a drop of Loctite, because that would be paired with your transformer now. So once you do the setup, you add the transformer and you adjust it and you do a Loctite drop, so this way you know it's done deal. Now, by the little magic of cameras, I have made another board. Except this heatsink is different. I'll get the other heatsink from work. It's only got 2 voltage regulators. The other 2 are blank. And as you can see, I've populated this. So the procedure is the same. Let me just swap the boards and I will show you. Here is both boards. Procedure is exactly the same with assembling and everything, except you can see that I've added a purple fuse, which is 3 amps, I believe it is, on the output, because that voltage regulator can only handle 3 amps. We've got again, oversized diode here. The diode is actually, I didn't have any smaller ones, so I had to use this one and bodge it in. Inductor, and again, you can use either multi-turn or single turn trim pot. I've used a multi-turn. They fit fine, so let's power it on. And that's working. Again, we can connect the battery. Just want to make sure there's nothing metal underneath. There we go. Same story. Its current is 1.1 and it's going to drop off now. There we go. So with this one, again, you adjust that little trim pod there until you set the desired voltage. Once you reach the desired voltage, then you can adjust this little trim pod to get your desired output voltage. In this case, I've already set it to 5 volts and it's measuring. Let me get this camera up. So the battery voltage is at the moment 13.3 volts and the output voltage is 5.1 volts. So that's ideal for 5.1 volt devices like battery chargers, clock, or whatever you may be using. And that's it. So again, that's staying cool. It will get warm if your battery is flat and you're charging it. The heatsink will get quite warm. But once the current will drop and the battery is fully charged, the heatsink will obviously cool off, well, unless you're drawing heaps of power from the output, but that shouldn't be the problem. So that's it. That's those 2 boards. I hope you find this project interesting. Leave your comments below. If you would have done anything differently, let me know. That's it for this project. There is another one coming up very soon. I've got the board somewhere. Actually, you know what? I am going to tease you. Let me disconnect this. I am going to tease you because the next project is going to be very interesting, and there's few people actually asking me about that, even offering to buy it, and I did sell quite a few online. So the next project is here. Oh no, it doesn't say anything on top, so that's all right then. Let me open that. That's a stencil for it, and I don't know if you'll be able to guess what it is, but that's it right here. It doesn't say anything on the stencil. No, so this is the hint. Take a guess what this could be. I can give you a hint that there's 2 boards. They divided right here. Well, it's the same board, it's just one side and another side of the board. What can this possibly be? Comment below and tell me what do you think that is. I may even give you a size-wise hint if I find the ruler. Oh, there's a PCBWay one. So each board is roughly 7.5 centimeters by 5 centimeters. What is this? Take a guess. That's it for this video. My name is Max. I will see you next time. Bye.